So as Eric's getting ready, I'll do a quick introduction. So Eric is works for the Department of Natural Resources. He is the Dodge County biologist. He started at Horicon in August, I believe, July or August. He came to us from the Kettle Moraine area, Washington County, and prior to that, Eric grew up and worked in Kansas. So,
Eric, if you want to mute yourself on your computer so we don't get any background noise. I see that there's a phone number called in, so I'm hoping if you unmute on your phone but mute on your computer, we might be good.
All right, you should be able to hear me now.
yes.
All right. Sorry about that. For some reason, my headset works for some communications and not for others.
Jeff, can you make sure you mute as well so we don't get any feedback from the auditorium?
Okay.
Thank you.
All right, we all set that then?
Yes, we're good.
Okay. All right. Well, thanks for the intro, Jeff. I wanted to turn my video on just for a little bit here, so I could say hi to everybody. Sorry for not being able to attend in person tonight. I don't know if Jeff told you, but I'm getting over COVID, so it wasn't fit to be in person with everybody tonight. But I wanted to say hi, and I'll jump right into it here. I am going to shut my video off so that I don't use up too much bandwidth here.
Eric, make sure you mute your computer too.
Yeah, it is. Are you guys getting feedback? I'm getting some through my phone too.
Yeah, a little bit. Everybody else should be muted.
All right, I'll share.
All right,
Can everyone see my screen?
Yeah.
Okay. Are you still getting feedback, Jeff? I was still getting some.
Eric, we're still getting feedback. It still shows that you're not muted on your computer. So I don't know if you want to mess with, click on it a couple times and see if we can get it muted.
Actually, the host could mute him too.
Also true.
Okay, let's try it now. How's that?
That's better.
Okay.
Better. Thank you.
Sorry about that. Yeah, I had muted my speaker, but not my microphone on the computer. So, okay, we are going to get this. Okay. So yeah, I guess as Jeff said, I started in August as the manager there at Horicon. Prior to that, I'd been in Washington and Ozaukee County as the DNR biologist over there, managing Shaw Marsh, Allenton, Jackson. Those are kind of the major properties over that way. So I guess to sort of start from the beginning and why are we managing water levels in the first place, or why do we even have to sort of interject management into these systems? And it kind of comes back to the degradation that occurred over the last 100 years for the most part. This picture is representative of an extreme example there that happened at Horicon Marsh, where miles of drainage ditch were dredged through the marsh in order to, well, the effect is essentially both lowering the water table so that less ground spatially is flooded at any time, but then also shunting that water off the landscape faster so that the hydro period, the amount of time that that water is on the landscape, is also shorter. So it sort of has a combined or two-dimensional effect on reducing the wetland effect, or the effect of the water on the landscape, and just reducing by extension the amount of wetland habitat that's out there. And so this was the ultimate effect at Horicon, was this main ditch dredged 14 miles north to south through the marsh, and then lateral ditches dug to the side to drain the marsh, and ultimately to convert it for a short time into agricultural ground. So it's the whole landscape, 33,000 acres of wetland removed for a time, and that type of hydrologic alteration wasn't restricted to the marsh. It was extended into the upland areas too, and most of it still exists today. So as you're driving around, it's not uncommon to see ditches in upland agricultural areas. And this screenshot here on the left is from our DNR surface water data viewer. And if you look on there, you can even just look on Google Maps, any web service that has a streams layer, and you can find these straight line, jagged stream courses that were ditched primarily in the 40s and 50s, and with the goal of getting water off of the landscape faster. So and you know, a lot of these, when they were dug, they were tied into existing wetlands, you know, draining those wetlands to make more ground available or suitable for agricultural purposes for the most part. Okay, and then in further upslope yet, we have a lot of this kind of work has been ongoing in the last few weeks, and happens every year, where agricultural drainage tile is installed to remove excess water from the surface layers, the surface several feet in farm fields, so that those fields are more accessible for agriculture. The ponding that occurs from being saturated by water is not ideal for agricultural crops, and so this tile moves that water off the landscape into these drainage ditches and creeks, and along with that oftentimes goes nutrients. And it also results in, you know, by giving that water a more direct line into our waterways, it also alters the hydro period downstream, where you get this more sort of rapid rise and fall. You know, the water gets into the waterways quicker, and then it having straightened and ditched waterways, it also exits quicker, and so we get more of a flashy system. Okay, and another effect on hydrology that we don't often think of, the ditches and the drainage tile. I mean, that's kind of an obvious thing to point to, but land conversion is a huge contributor to just the amount of water that can be stored in the soil, and the amount of water that can either infiltrate into groundwater or runs off the surface. Agricultural soil, when the perennial vegetation has been removed, it tends to lose pore space. So a native soil will have a great deal of macro and micro pores, so holes essentially in the soil where gas exchange occurs, and this pore space allows for water to infiltrate into the soil and to be stored in the soil. But when the vegetation is removed and those root channels are removed, and then farm equipment is run over this soil or the site's heavily grazed, a lot of those pore spaces start to break down. And certainly if the soil is tilled, then those pore spaces break down. And over time, especially the tilled soil can turn almost rock hard in some situations because it's lost the chemistry and that pore space as well that helps it have more of that, the garden soil that we tend to think of. It sort of changes its consistency entirely. Perennial vegetation and perennial plant communities, forests, grasslands, wetlands also contribute annually a significant amount of litter, so leaf litter, grass litter, and this litter or organic material is over time worked into the soil, partially decomposed into the soil, and organic matter has a strong, is able to bind to water and really absorb water. So in an agricultural setting where you don't have as much plant residue, again, we don't get as much water storage. So that water tends to move into our waterways more quickly. Okay, here's a map of land cover in Dodge County. I would say our dominant native land cover still remaining is wetland. There's very little of this dark green forested cover, even less maybe of this pinkish colored grassland. We are dominated by agricultural land, and then there's a fair amount of urban or developed land in certain places too, but certainly our landscape has been hugely altered. And another reason why we have to take a hands-on approach with wetland and water level management in wetlands is because of invasive species. Here's just a couple, there are several, but the effects of carp and cattails change the way these wetlands function to the point that we have to be very hands-on with our management. So carp will root in vegetation, and when they're rooting and uprooting and destroying some of the native vegetation, they can also suspend sediments and nutrients, which can inhibit light penetration through the water. The suspension of nutrients can lead to growth of algae in the water and further limit light penetration. And then cattails are another major challenge for us. A lot of times we think of cattails as a very beneficial wetland plant, and in a way they are. They're a wonderful filter. They can pull a lot of toxins out of the water and heavy metals out of the water, and they filter sediment. But from a wildlife habitat standpoint, they're not ideal. And the cattails that we're dealing with today, in most cases, are not our native cattail. They're either the invasive narrowleaf cattail, or the hybrid between our native broadleaf and the invasive narrowleaf. And that's typically what we're dealing with, is these hybrid cattails, which have sort of taken on some of the traits of both parent species. The native broadleaf cattail tends to favor shallower water. The invasive narrowleaf tends to be better adapted toward deeper water. And this hybrid, it can survive over a wide range of water depths, from essentially moist soil to water almost 4 feet deep. It grows to be 10 feet tall, produces a tremendous amount of biomass, especially in a high nutrient environment compared to native species. Hybrid cattail can really respond in the presence of high nutrients, so fertilizers. So we're thinking about agricultural runoff for the most part, so nitrogen, phosphorus in our waterways. these cattails can really absorb those nutrients and turn them into biomass. But in doing that, they can, through the accumulation of biomass, exclude native species and lead us toward an environment that's dominated just by hybrid cattail. So can you see my cursor when I try to walk you through this?
Yes.
That's showing up on the screen. Okay, great. Okay, so there's two sort of recognized drivers of cattail invasion. So they're altered hydrology, and specifically artificially stabilized and raised water levels. Cattail prefers shallow, stable water. So if we have artificially raised and stabilized water levels combined with increased nutrient inputs, as I said, the cattail can produce abundant growth. With that abundant growth comes abundant litter, and we go into this this feedback loop where the cattail's litter accumulates on the site. It has this mulching effect, just like you would have with a garden mulch. That mulch suppresses the native plants. The cattail is actually able to grow very well in its own mulch. So this creates sort of a space for further cattail expansion. The cattail actually changes the environment of the wetland. So the mulch reduces light, the amount of light that's hitting the soil surface. It reduces the soil temperature. It also reduces the variation in soil temperature, and that turns out to be important because some wetland plants are triggered to germinate by that change in temperature. So the litter sort of acts as a blanket and stabilizes the temperature, keeps it cool. That inhibits other plants from germinating. Obviously, there's a physical effect where that light isn't getting through, so seeds not germinating that way. And then the cooler temperature at the soil surface also slows microbial decomposition, so that litter tends to persist for longer. And over time, it builds up, and you can kind of see in the background of this picture, this is the soil surface, and all of this right here is accumulated litter biomass. So under these cattails, you'll find a foot or a foot and a half thick of this accumulated litter, and that floats. The cattail roots can be very punky, filled with air. They need to be able to pump that oxygen from their leaves down to their below ground parts in order to survive in these wetlands. So they can be very punky and filled with air. And if water depth gets deep enough, they will float, which can cause a number of issues for navigation, for infrastructure on waterways. So these are things also that we have to take into consideration when managing water levels. And then there's a number of dams now on the landscape, and dams can be, we obviously use them to try to produce wildlife habitat. There's also dams that they affect water in ways that may damage habitat. And so there's good and bad potential there. It just depends on how they're managed and what the goals are for a specific dam. Different dams have different goals. Many aren't designed necessarily for wildlife benefit. They may be recreational or as a water source. Here's a schematic of the Rock River watershed from the Hustisford Dam upstream through Horicon National Wildlife Refuge. It's operating on two different scales here. So going across columns is going upstream We got the Hustisford Dam down here, the Horicon State Dam that's in the city of Horicon right here, and then the federal dam that divides the state wildlife area and the National Wildlife Refuge is right here. So this is stream miles going upstream, about not quite 10 miles between those, about 6 miles to the federal dam. This is a different scale going up and down here. On this scale, each row height represents about 2 inches. So this is sort of to scale the height of the Hustisford Dam. And these are actual key elevations there. So you can see the effect that the Hustisford Dam has on the system. If they're at their ordered max, they can have a strong influence on the water level throughout both the state wildlife area and the National Wildlife Refuge. The National Wildlife Refuge, their full drawdown, which we're going to talk about drawdowns in a little while here and why they're so important, it is at 854.4 feet. The state wildlife area, our maximum drawdown is about 852. In order for us to be able to reach those goals and dewater the marshes periodically, we would need cooperation from the operators of the Hustisford Dam to be able to reach those goals. So there are other interests too and other challenges beyond the ecological challenges. There's different goals throughout the watershed. And then there are also legal restrictions. So with any dam, there are restrictions placed on it. The dam can only be managed within certain limits. So I guess I'll go back here. The Horicon Dam and all of these dams have an ordered maximum. So the Hustisford Dam, this is as high as they can hold water. The Horicon Dam, this is as high as we can hold water. Hustisford also has an ordered minimum. Our dam, the Horicon Wildlife Area Dam, does not have an ordered minimum, but we do have a minimum release rate where we have to pass a certain amount of water downstream. And then we also have restrictions on during the growing season. We can't pass too much water. Specifically, if we're in a flood situation, we can't also be dewatering. So we shouldn't be sending more volume downstream than the natural runoff, essentially, of the marsh, because we don't want to exacerbate that flood situation for folks downstream. Okay, and then the last sort of contributing challenge is changes in climate. This is a look at roughly the last 120 years. You can see there's sort of a trend toward more green. So this is these are periods of wetter conditions. So and there's longer and more frequent wet periods. So we had 2018, 2019, 2020 were all very wet years. 2004, 2008 were very wet years. And then if you go back into, 93 was a very wet year. But we're seeing, in the last 30 years, fewer of these drought cycles. And the next thing I'm going to kind of go into here is that when it comes to wetland management, the drought cycles are just as important as the wet cycles. We tend to think of wetlands as needing water, but it is absolutely critical that they periodically go dry. Going dry allows these wetlands, it's part of a cycle that leads to the productivity of the wetland. Okay, and then we also have variation that occurs within a given year. So we have precipitation patterns, spring melt, these kind of things increase flow during the spring, and then we tend to have lower water conditions throughout the fall. Now we don't always manage our wetlands that way to follow this. I mean, certainly we do see a spike in spring, but we don't always allow those wetlands to go low in the fall because, you know, we have other recreational interests where folks want to get out onto some of these wetlands and do some waterfowl hunting. So we don't always mimic the natural hydrology as closely as we could because there are other competing interests. Okay, so here is the wetland cycle. So when wetlands go dry, vegetation germinates, and then you get this flush of growth over time as water fills in the basin. You're moving into a period of more moisture. This isn't necessarily annual precipitation. This is thinking more over the period of years. Higher water returns. As that higher water returns, wildlife get into some of these stands and they tend to consume some of the vegetation. Muskrats, you know, is starting to get broken down. The high water starts to decompose and break down some of the plants. And so we go from this regenerating condition where the vegetation is accumulating in the basin to where it starts to then degenerate and starts to break down. And eventually, with high water for long enough, we'll eventually end up with a lake marsh situation, which then when it goes dry next, it'll sort of restart the cycle. And the productivity of the cycle exists because when this vegetation grows, it produces seeds, it attracts bugs. And the productivity that I'm really talking about is productivity for all kinds of life, but in most situations, I'm probably going to be referring to waterfowl here. The vegetation attracts bugs that are feeding on the vegetation, and then predator insects that are feeding on those. It attracts small vertebrates. We got, like I said, seed production from the plants. There's green vegetation that's consumed by wildlife. And then as we move into the degenerating marsh stage, we still have a number of macroinvertebrates that are decomposing this and that are still forming something of a base to the food chain. As we move more into the lake marsh condition, we tend to lose that productivity, and we're left with fewer invertebrates there, and certainly fewer that are accessible on the top surface of the water for consumption. Okay, so it's important for these wetlands to be dewatered periodically. This was a wetland unit that was dewatered, I believe, starting in late April, and it was pretty dry, which was the goal. The goal being to favor certain species to germinate, but not others. So cattail has very specific germination requirements where it needs soil moisture. It needs something of a film of water on the soil surface. If the soil surface is essentially dry like this is, the seed can't germinate. It also needs to have full sunlight and warm conditions. Cattail seed germinates at its peak in about July or August, but it will germinate from May through September. So the goal here was to sort of get out ahead of those warm temperatures, get the water off the site. This peat soil really holds moisture well enough, but there wasn't a concern of getting it too dry. In some areas where you've got mineral soil and you can dry that soil out really quickly, if you dewater these basins too fast, not only is it hard on the wildlife that are burrowing into that substrate to survive the simulated drought, but it's lost my train of thought there. Sorry about that. Well, maybe it'll come back to me here. Okay. So these droughts or simulated droughts are quite destructive, as you can kind of see. You're changing the local environment significantly, where you're going from a site. Well, the difference between a site that has water and a site that doesn't have water is pretty significant. So you're removing that. You're changing the suitability of that site for a number of wildlife species. Some obviously will be attracted to it. Some will have to relocate or burrow to be able to survive that situation. And so we need to sort of be considerate of that, or be thoughtful in how we're managing the landscape so that we're not overly destructive. And one way that we do that is to sort of implement this wetland cycle or simulated wetland cycle in rotation. So out on Horicon Marsh, we have these constructed wetlands where we have pretty good water level control. And so we can sort of independently de-water some, have some in that regeneration stage, while we have others in the lake stage, so that we're providing habitat for an array of wildlife. Okay, so here's a look at year one. So prior to dewatering this site, this would have all been open water. I think this picture was probably taken in about June, probably June. You can see there's still quite a bit of mudflat here as the water continues to recede. The vegetation that's growing here is largely annual species in this first year. And then a little bit later in the year, those annuals, barnyard grass shown in this picture, have grown to be dense, 5-6 feet tall. These seed heads were over a foot long, loaded with seed. There's rice cut grass in here. It's full of bugs. And then we get this wonderful diversity of habitats, where we've got mudflats out here, tremendous shorebird habitat. The site was full of life. And then going into September, these stands are absolutely dense. And when you start to put water back in them, you can't even see the water. And so in some places, managers will actually go in and sort of pre-mow some strips or even disc some strips so that water can be visible. But I've found that in most situations, the birds from up above, they can see that water and they get into it, and they start beating around in that vegetation, and they'll get it knocked down, and they're after those seeds, and it doesn't take long for them to knock that down. So something else that happens when these sites are dewatered is we start to see other vegetation growing in, particularly among these persistent cattails, which if you're not starting out with a perfect lake stage situation, you probably have some other vegetation growing in there already. And for us, for the most part, it's persistent cattail. But by dewatering that site, now other vegetation starts to grow in there and kind of compete with that cattail. And in this situation, we had this vine that was starting to spread out over extensive areas of cattail and kind of drag it to the ground and cover it. We had abundant jewelweed growing in among the cattail, bulrushes starting to compete. Okay, so now we're going to kind of move into returning water to the site, so moving more into that the HMBC Marsh stage. So this was, now we put water back onto the site, and this is actually within just a few months of putting water back onto that same site we were just looking at. So we went from annual vegetation 5 or 6 feet tall to essentially that vegetation has gotten beat down both by just being saturated and by the action of waterfowl getting in there to use it. And muskrats are are very attracted to these sites too. Soft stem bulrush, hard stem bulrush, they get in there. Smartweed too. They'll cut that and use that for feeding and for their lodges. And then this is the following spring. The area shown in open water was, again, it was sort of that 5 and 6 foot tall vegetation. You can see some of those little stems still poking up there, but for the most part, that's been totally laid down. I think this picture was taken in March. All the cattail that's still visible there, that was present before the drawdown occurred. So the site obviously still attracting a lot of waterfowl to it. There's still a lot of bugs in that vegetation that's been knocked down. And then if we look a month later, so we dewatered this site again for a second year then, and this is what's left of that annual vegetation. It's sort of been flattened out, but there's a lot of bugs in there. There's a lot of snails in there. Here's just to kind of go back a little bit. And I was talking about the cattails with the accumulated litter in the roots. You can kind of see that here under some of these little cattail clumps, how they've got sort of that accumulated litter. And most of these floated in when the water level was higher, and then when the water dropped, that's where they settled out. Okay, so year 2 then, dewatering, we started to see more perennial plants. So we still got some smartweeds, but we saw a lot more hard stem and soft stem bulrush, so more persistent plants. We still had some of the annuals, but now we're getting a different community, and we put water back on this, and now this would be an area where I would expect to see a number of waterfowl broods. It's starting to produce a little bit different, a different community here. Our filamentous algae can attract and hold a lot of invertebrates. So this is a great source for both protein and for carbohydrates. So this would be, this is our sort of ultimate goal for a hemi marsh, a site that'll produce habitat for both brood rearing, but also for stopover migration habitat. Okay, so then we're starting to move from the hemi marsh stage toward the lake marsh stage. This aerial photo was taken in 2008 during the flooding. You can see the lime green areas along the waterways. These are areas, deeper water areas that were stressed by the high water. And so you can see the vegetation there starting to be stressed and kind of suffer from that persistent deep water. And even though certain cattail can survive water 3 or 4 feet deep, it can't do it forever. Even at 2.5 feet deep, if that water is maintained on the site for long enough, that cattail will start to get stressed. It may float, but in a floating situation, it's not in an optimal environment. And so the survival is poor. Up at the National Wildlife Refuge, they've even found that the cattail itself will die on some of those floating mats, and then annual vegetation will germinate. So you'll essentially have sort of that regeneration stage occurring on top of these floating cattail mats. And it's kind of a remarkable situation. Okay, so here again, lake stage development. This is the National Wildlife Refuge. Picture on the left was from 2008, same as the picture from just downstream. And then the picture on the right is from 2018. And you can see how much main pool in the National Wildlife Refuge has opened up from persistent high water. So they haven't dewatered the main pool there for many years, and so it's moving into this this lake marsh stage and becoming less productive. It's only a foot and a half deep, but with the amount of sediment that we have, the carp that we have, the water clarity is poor, submergent vegetation isn't growing. The only way that they're going to be able to revegetate the site and get some productivity going would be to dewater it entirely. Okay, so here again is kind of that floating cattail where you've got in shallow water areas for the rooting, and then it floats in the deeper water areas. Okay, so when the cattail floats, it can be difficult to reset the system, to get it to go to an open lake stage, to where we can then dewater it and start the cycle over again. So sometimes we use other tools like herbicide to help move the system that way. So we hit the chemical or hit the cattail and other invasives like Phragmites with some herbicide, and then we usually follow that up with, I'm getting ahead of myself here. So let me stop right there. The herbicide doesn't work equally well everywhere, and it's fairly expensive to apply, and we don't want to apply it unnecessarily. So we have to be pretty targeted in where we go with it. So I spent some time looking at past treatments, areas where herbicide was applied at Horicon Marsh, and where it was combined with prescribed fire and how it was combined with the fire, and sort of what the ultimate effect of that was. How long was open water produced, or how long could I still see the effects of that treatment? And ultimately, kind of the conclusion I came up with, which makes sense with this wetland cycle concept, is that we need to be treating these deeper water areas where we can spray that off, get it to a late stage, and then dewater it. So that's really how I'm going to target application going forward. It's going to be these deeper water areas, or areas where there is stream flow. That also seems to help. If you've got a little flow to the area, the effect seems to last longer. Okay, and then like I said, a lot of times we'll pair that with prescribed fire. The fire can be used either ahead of or following the chemical. A lot of times we've used it after chemical in order to remove the litter, to sort of prep the site for seed germination. I'm going to try using it ahead of the chemical to both do that, clean off most of the litter, and then also with the flush of vegetation that comes back, I'm hopeful that we'll be able to get better herbicide contact. A lot of the historic treatments that I was looking at, it was very obvious where high quality chemical contact had occurred and where it had not, and where application was poor, the effect was minimal. It was essentially a useless treatment, but where good chemical contact was achieved, the effect could last for several years. Okay, and then like I said, in other places, not so much here, but in drier environments, rather than using herbicide during the lake stage to sort of reset that cycle, they'll use an agricultural disc and go in, dry the site out, go in and disc some of that vegetation down. A lot of times that may be invasive species control, or it may be simply resetting the site to annual vegetation. So it's knocking down some of the perennials to get a more diverse plant community. Annuals tend to produce more and larger seeds, which have higher energy content. they'll attract a different assortment of invertebrates. So this is just a different way to sort of reset that cycle and increase wetland productivity. Okay. So then we've kind of come full circle through the whole cycle. And again, that's the process of producing that productivity in the wetland comes from the whole cycle. If we try to remove one piece of the cycle, so a lot of times we're looking at this this hemi-marsh stage as sort of the ideal because we've got stopover habitat, we've got brood rearing habitat. We want to pull this out, and we don't want to necessarily have to go through these because this takes time. We want to just hold it here. We can't do that. If we pull these out, we lose the growth. We lose all the seed and the bugs that come from this regeneration portion, and we may end up with something that kind of looks like a hemi-marsh, but it doesn't act like a hemi-marsh. Okay, and so as I was talking about, sort of the productivity of the wetland, a lot of times we're thinking about what are the needs of the species that are moving through these areas, and traditionally, at least for waterfowl, the focus has been on energy because that's what they need during fall when they're moving through during hunting season. So it's how can we put calories out there to attract those birds, but protein is highly important. It's important sort of throughout the entire year. They need protein for egg production. They need protein for molting, and so we need to be thinking about how also can we produce or put protein out there, make it available for them. And so we got to look at sources of protein and sources of energy. And for the most part, when we're thinking about protein, we're thinking about bugs. That's quite a little packet of protein right there. But then waterfowl can also get protein from other plant parts, new growth vegetation, seeds from Biden's foxtail, rice cutgrass are all high in protein. So those are good sources. And then energy, as I said, for the most part, we're thinking about seeds, particularly from annual vegetation. Obviously, acorns are a big one. We don't have a whole lot of that in marshes, but if you're in a forested wetland, that can be a big contributor. Grain and flooded crop fields, some invertebrates, and the fats from invertebrates that'll have a lot of energy in it. So those are the energy and protein sources that we're trying to produce out there through this process. Okay. One other thing I'd like to point out is we tend to look at wetlands and think that we need a lot of water or we need more water. The sort of optimal or ideal foraging depth for most of our birds is very shallow water. You can see that most of these fall at 12 inches or below. Few of them will feed out to, maybe 1.5 feet, but for the most part, their ideal also is down around 12 inches. So we don't need to have a whole lot of water out there. It does help though to be able to put deep water on sites to regenerate that cycle though. Okay, so this is my final slide, and it's kind of a quiz slide. So anybody can chime in, or it can just be food for thought for a few minutes. But this is a wetland that I used to manage, and I'm curious what everyone thinks as to whether or not this would qualify as a hemi-marsh. We can ponder that for a little bit, and if anybody wants to chime in, great. Otherwise, I can spoil it. because I did have one individual tell me that that they thought this looked like, I'm trying to think of how he worded it, pretty much perfect, I think was how it was worded. And I had to disagree with him. This wetland was pretty much a combination of cattail, which you can see here. This is all just dead cattail, and open water. It looked good, right? It's got the interspersion of water and vegetation. This wetland was essentially lifeless. It had not been dewatered for many years. I rarely saw birds on it. During the breeding season, I maybe saw a pair, but during migration, I saw nothing. It was essentially lifeless. So I would say this would be the condition where it looks like a hemi-marsh, but it's not acting like a hemi-marsh. It's been disconnected from the cycle, and we're not getting that productivity. All right, that's all I got, Jeff.
Okie doke. Well, thanks, Eric. Anybody else have any questions? I just one comment here before that last slide you had there. One component was missing. There was no submergent vegetation, and that was one of your key ingredients into a healthy marsh. There, you did not see any plants growing below the surface of water. It was just kind of almost like a puddle with some cattails. Am I correct?
Yeah, that's absolutely right. I would add to that, Jeff, that I rarely see wetlands that have a good submergent vegetation community. Some that are sort of disconnected from a riverway, that are protected from carp, or where the carp aren't present, they can have a good submergent community. But where carp get in there and stir things up, for the most part, we tend to see a muck bottom, where really we're not getting much going on.
So there's a question there in the chat, if you can take care of that one.
Yep. So yeah, Margaret, some cattails are native, some are not native. So there's many species. The cattails that are native to our area are cattails. They tend to favor shallower water areas. They don't grow in these sort of vast single species stands that we see in a lot of places, particularly like Horicon. The narrow leaf cattail is the exotic invasive. It's native to Europe. It was introduced here somewhere on the East Coast, hybridized with the native broadleaf, and now most of what we see and sort of struggle against is a combination of the narrow leaf and the hybrid. I honestly see very little of the broadleaf cattail. Where I do, it's usually mixed in with canary grass. So it's sort of more on that drier end of the wetland spectrum. The floating boardwalk project. I'm not sure. I'm not sure what that is, Amy. Where was that occurring?
Oh,
Yeah, Amy, go ahead.
Are you talking?
yeah, it's a,
Oh, okay. So up on the National Wildlife Refuge, I don't know. So that's not an area that I cover. So I don't know what they've got going on up there. If anybody else does, feel free to chime in.
I'll just chime in a little bit of what I know about I don't know if anything continuing, but what is happening there, they drew it down. What's coming back is not cattails, which is a very, very good thing. And I know they were doing possibly a little dredging on either side of it to try to get some more flow. It kind of basically clogged with cattails. I know from like the last open water before you leave the auto tour, that water control structure below there was clogged with cattails, so there was no water movement going down towards the auto tour or towards the floating boardwalk. That's about what I know. Jane's got a question. They're non-chemical options to kill cattails.
Yeah, there are. Those options become difficult and in some cases cost prohibitive or time prohibitive. But yeah, I can definitely go through those. So flooding is an option. If you can put enough water on a site, like I said, 3 or 4 feet of water, and hold that for, it may be several years. Eventually the cattail will die. It may float first. Eventually it will die. But again, there's challenges with that too, because that floating cattail, it likes to break free into clumps, which if you're on a waterway, that can impede navigation. It can cause flooding in other places. It can damage infrastructure like boat ramps or plug dams and cause issues there. But yeah, if that is a tool that we use, especially in like some of these managed impoundments where we're separated from a waterway. We can hold the water high for several years. The National Wildlife Refuge uses that strategy a lot. And then they'll, like I was saying, we can kind of pair that with herbicide. So if we've flooded it for long enough, and we've sort of gotten as far as we can with flooding, then we can bring in the herbicide, sort of kill what's left, and then start over. We don't really want to have some of those cattails left over, because then when we dewater, they'll start spreading out again. So we kind of like to start clean. Another strategy that's used is if you can cut those cattails below the water line, or cut them and then flood above them, you can essentially drown them out. The cattail needs to have stem tissue above the water surface to be able to pump oxygen below the water to keep its below ground parts alive. So if you can cut that, put water, even just a few inches of water over that, you can kill it. But that takes special equipment to be able to go out and do that. And a lot of times that equipment operates very slowly. So, I mean, you're talking about a tool that can, maybe treat a few acres per day, which if you've got a small area, that might be just the ticket. Another option might be if you have a site that you can wait until winter when it freezes. You might be able to go out and mow it, and then if it floods in spring, that might be able to do it too. But you've got to be able to keep water over it for quite a while before you're going to flood those out too. One strategy that I'm looking to try here this next year is a little bit of a twist on that, where we're going to dewater one of the impoundments this year, burn it this fall, sort of wait until the end of the growing season, till all the cattail senesces, burn it all to the ground, and then flood it all winter long. Sort of wait until there's no chance that the cattail is going to regrow, and then we can flood over it and see what kind of control we can get. Disking is another option. Summer burning has been tried. Summer burning works a little bit better than winter burning. You can decrease both the above ground growth, but also you can sort of impair the below ground parts too, or really rob those plants of some of their energy. Simply burning in the winter time without any other treatment really doesn't have much of an effect. You remove a few years of litter, which might let some other plants grow, but really that cattail is going to respond back the same year with the same density or maybe more. Next question.
Eric, when you bring this down to drought stage, do you ever have to add seeds, or are the seeds that are in the soil sufficient?
Yeah, no, the seed that's in the soil is typically sufficient, especially in our area. When I worked in Kansas, some of the areas that we were managing, we did go in and plant. I don't think we would need to, and now if I were back there doing that again, I wouldn't. In that situation, it's a drier environment, and so you have to be much more careful about dewatering, because if you dewater too quickly, you can end up with either undesirable plants or upland plants, which also are undesirable. And so you have to, the timing of dewatering plays a big role, whether you dewater in the spring, early summer, or late summer. The rate of dewatering matters. Even honestly, the amount of cloud cover that you have on a certain day can affect the species that germinate. The temperature affects it. It can be pretty picky. What I've found up here is that our wetlands tend to be more resilient. If I can get the water off of it, the native plants will just respond with a great variety.
Thank you.
Eric, question from Anne in the chat. Can you take that?
Yeah. Yeah, so Sinnissippi historically would have been very similar to Horicon, where it would have been a low marshy area, and it sort of has a very similar history to Horicon too, because Horicon was at one point dammed and was managed as a lake, and then eventually dewatered, and now Sinnissippi is managed that way. Sinnissippi right now, the Lake Association is working on a lake management plan because there are a number of challenges that they're facing with shallow water due to sedimentation. There's sedimentation presumably from both from upstream runoff, but also possibly from the disintegration of islands in the lake. So there have been a few of the islands that have sort of just disintegrated from persistent high water. The banks of those islands have lost their vegetation because of that high water, and then the soil becomes saturated and it sort of just dissolves and settles into the lake. And so now they're really struggling with navigability in a lot of places, and they're looking at options to improve that. The fishery is struggling. There's a lot of carp in Sinnissippi, and so they're looking for options there. In the past, they have dewatered the lake in order to control carp. They got a lot of cattails that responded, and I think this was in the 70s, and then they struggled to get rid of those. And so I don't know if they're going to have any interest in dewatering again, but dewatering may have some really good and sort of cheap benefits. I've found that when we can get the water off of a site, the sediment compresses and consolidates the water. When you start to lower it and it becomes focused within those waterways, stream velocity kind of increases as it's almost like a jet, right? You sort of focus it down within the waterway, and then it's able to carry more sediment. And so essentially, just getting the water off of it can flush out some of those waterways. And then I was actually on a call with them, when was that, Tuesday night? Yeah, we were talking about it Tuesday night, and I shared some of this same information about, well, if if you try to do a drawdown early and do it for only 1 year compared to multiple years, as was done in the 70s, you may be able to get just an annual plant response that then will disintegrate over the following winter and not lead to this persistent perennial vegetation that's been a problem there in the past.
Eric, question from our audience here at the center. Question was, what would happen if all 3 dams were removed?
Well, if all 3 dams were removed, that's a good question, big question. The drainage ditches in the marsh still exist. So it'd be my expectation that we would move too far the other way. So the natural hydrology there would be we'd be too dry, and we would sort of drive the marsh specifically. So Sinnissippi would I think respond a little bit differently. I think that would probably go to more of a natural marsh condition. Horicon, given all of the drainage ditches, would have a shorter than natural hydro period, and I don't think we would see the vegetation that we would want to see out there. It would essentially be small trickles of creek water, and then undesirable vegetation that never really floods.
Yeah, because Horicon would probably be in the upper half of the watershed, and Sinnissippi be in the lower half of that watershed. Yeah, and the amount of drainage coming in there, it would kind of make sense that Sinnissippi would stay a little wetter.
Well, and Sinnissippi also has, it's got, if you removed the dam there, they would have, sort of a more natural flow and rise and fall of water going through the site, versus the way that the water would move through the drainage ditches. That water table with the drainage ditches has already been lowered by several feet, and so those upper feet of soil aren't going to get the water that they need to be a productive wetland. But that's an interesting idea, and our dam in Horicon is 92 years old and was designed for a 100-year lifespan, and it's got a major crack on the east side, and so we're thinking about, well, where do we go from here? And right now, when the Sinnissippi Dam is at its ordered max, we have about 7 inches of water level control, which isn't very much. And so I'm trying to think of, well, how can we design or select a dam design that would allow us to have a more natural hydrology? And there's been a lot of development in dam design in the last 100 years. And one component that I've been looking at is they're called crest gates. They essentially flow over the top rather than as a bottom draw gate, which we're using right now. We're using these bottom draw gates and a combination of stop log bays. But these overflow gates would allow us to kind of set an elevation, and then I think let the natural sort of natural sort of fluctuation in the water level from seasonal and interannual precipitation sort of do its thing, versus right now we're bottom drawing, and then the dam below us is managing for stability. We sort of receive that same stability, and so our water level tends to stay relatively stable. And if it had more of that natural rise and fall, I'd like to think that we would see a change toward maybe a more diverse plant community, but we're also heavily invaded by invasive species, and so it may take years before something like that would happen.
One last call for questions for Eric. Hearing none, I want to thank Eric for giving tonight's presentation. A very thought-provoking. Oops. Did I kill it? There we go. Sorry. Want to thank Eric for the wonderful presentation. If you would like to kind of compare things, those that are familiar with Mud Lake Wildlife Area in southern Dodge County, go down there a little bit and take a walk around. You're going to see a much more diversity of vegetation, and that's because it still has its hydrology intact. So you'll see these big flood events, you'll see these big drought events. So that in itself kind of takes care and helps the diversity of the plant and wildlife areas, or the usage. A thing that we kind of look for here at Horicon, and anywhere else, if you see coots are a very good indicator of the health of your wetland. So they require that clean water. They require that submergent vegetation. You know, the last couple of years we haven't seen many coots around. So I can remember right after the last drawdown in carp treatment, back, I think that was about 1999, 2000. Right after that, I mean, the coot population was, I mean, I haven't seen that many in years. So that's going to kind of give a good indicator of the health of your wetland. So with that, Eric, I want to thank you. Thanks for coming in, and we hope to see more of you around. If anybody has any questions, and that's just not tonight, but questions about the marsh in general, a question about habitat management and things, feel free to reach out to Eric. He'd be a wonderful resource, and he's looking forward to hearing from you. So with that, I want to thank everybody.
Jeff.
Yes. Go ahead, Eric.
Yeah, and I just wanted to say thank you to everybody. I appreciate the invite. Excellent point on referencing Mud Lake. Yeah, that is a spot that doesn't get as much attention as Horicon, but it's a fantastic reference for likely what Horicon would have looked like, you know, on a much smaller scale, but an example. So yeah, definitely check that out if you haven't been there before.
All right. Thanks.